What is site reliability engineering? In this video, we'll provide an overview of site reliability engineering, SRE, what it is, how it works, and why it's an essential practice for modern software development and operations teams. We'll cover the core principles and best practices of SRE to help you understand how it can benefit your organization. Site reliability engineering, or SRE for short, is a discipline that combines software engineering and operations to build and run large-scale, distributed, fault-tolerant systems. It was pioneered at Google in the early 2000s and has since been widely adopted by leading technology companies around the world. The core idea behind SRE is to treat operations work like software development, applying the same rigor, testing, and engineering best practices to infrastructure and system management as you would to building applications. The goal is to create highly reliable and scalable systems that can withstand failures and deliver consistent performance. In this video, we'll explore the key principles and practices of site reliability engineering and discuss why it has become such an essential part of modern software development. By the end, you'll have a solid understanding of what SRE is, how it works, and how your organization can benefit from adopting an SRE approach. What is site reliability engineering? Site reliability engineering is a discipline that combines software engineering and IT operations. The core idea is to apply software engineering best practices, tools, and methodologies to the work of operating and maintaining complex distributed systems. Rather than treating operations as a separate function from development, SRE aims to integrate the two disciplines. Reliability engineers work alongside software developers to build systems that are highly available, scalable, and resilient to failures. Some of the key principles and practices of site reliability engineering include 1. Automation. SREs focus heavily on automating routine operational tasks like provisioning infrastructure, deploying software, monitoring systems, and responding to incidents. This helps eliminate manual errors and frees up time for more strategic work. 2. Measurement and observability. SREs put a strong emphasis on instrumentation, monitoring, and telemetry to gain deep visibility into the behavior and performance of their systems. This allows them to quickly detect and resolve issues before they impact end users. 3. Error budgets. SREs use the concept of error budgets to balance the need for reliability with the need for innovation. They define an acceptable level of error or downtime, and then work to ensure the system stays within that budget. 4. Blameless postmortems. When incidents do occur, SREs conduct thorough, blameless postmortem reviews to understand the root causes and identify opportunities to improve. The goal is to foster a culture of continuous learning and improvement. 5. On-call rotations. SREs often participate in on-call rotations to ensure there is always someone available to respond to and resolve production issues in a timely manner. 6. Scalability and capacity planning. SREs focus on designing systems that can automatically scale up and down to meet changing demand, and they use sophisticated capacity planning techniques to ensure there is always enough infrastructure to support the workload. By applying these principles, SREs are able to build and operate highly reliable, scalable, and efficient systems that can withstand failures and deliver consistently great performance for end users. Why is SRE important? In today's digital world, reliable and scalable infrastructure is critical for businesses of all sizes. Customers and users expect applications to be available 24/7, with zero tolerance for downtime or poor performance. At the same time, the complexity of modern software systems is increasing exponentially. Microservices, containers, serverless functions, and distributed data stores have made it much harder to maintain consistent reliability and availability. This is where site reliability engineering comes in. SRE provides a structured, engineering-driven approach to managing the reliability and scalability of complex distributed systems. By applying software engineering best practices to operations, SREs are able to 1. Reduce downtime and incidents. Through automation, monitoring, and incident response processes, SREs can detect and resolve issues faster, minimizing the impact on end users. 2. Improve system scalability. SREs use techniques like capacity planning and automated scaling to ensure systems can handle increasing traffic and workloads without performance degradation. 3. Enable faster innovation. By taking the operational burden off developers' shoulders, SREs free up time and resources for the engineering team to focus on building new features and capabilities. 4. Foster a culture of reliability. SRE practices like blameless postmortems and error budgets help create a culture where reliability is a shared responsibility, not just an operations function. 5. Reduce operational costs. Automation, self-healing systems, and better resource utilization all contribute to lower operational costs over time. In short, site reliability engineering is a critical discipline for any organization that relies on complex, distributed software systems to power its products and services. By adopting an SRE approach, companies can build more reliable, scalable, and efficient infrastructure to support their business goals. SRE in practice. So, how do site reliability engineers put these principles into practice? Here are some of the key activities and responsibilities of an SRE team. 1. Infrastructure provisioning and configuration. SREs use infrastructure as code tools like Terraform, CloudFormation, or Ansible to automate the provisioning and configuration of compute, storage, and networking resources. 2. Software deployment and release management. SREs work closely with developers to automate the deployment of software updates and new features, using practices like continuous integration, canary releases, and blue-green deployments. 3. Monitoring and alerting. SREs design and implement comprehensive monitoring solutions to track the health and performance of all system components, setting up alerts to notify the team of any issues or anomalies. 4. Incident response and remediation. When incidents do occur, SREs lead the investigation and resolution process, using techniques like runbooks, playbooks, and postmortems to identify root causes and prevent future recurrence. 5. Capacity planning and optimization. SREs analyze usage patterns and forecasts to ensure there is always enough infrastructure capacity to handle expected workloads, and they work to optimize resource utilization to reduce costs. 6. Reliability engineering. SREs apply reliability engineering principles like fault injection, chaos engineering, and load testing to help identify and fix weaknesses in the system before they cause problems. 7. Knowledge sharing and collaboration. SREs document their work, share learnings, and collaborate closely with developers, product managers, and other stakeholders to drive continuous improvement. By executing these responsibilities with rigor and discipline, SRE teams help organizations build and operate highly reliable, scalable, and efficient software systems that can withstand failures and deliver consistent performance for end users. Conclusion. In conclusion, site reliability engineering is a critical discipline for modern software development and operations teams. By combining software engineering best practices with a focus on reliability and scalability, SREs are able to build and maintain complex distributed systems that are highly available, resilient, and efficient. Whether you're a small startup or a large enterprise, adopting an SRE approach can provide significant benefits for your organization, including reduced downtime, faster innovation, lower operational costs, and a stronger culture of reliability. If you're interested in learning more about site reliability engineering and how it can help your business, I encourage you to explore the wealth of resources available online, including books, blog posts, and online courses. And don't hesitate to reach out to experienced SRE practitioners who can share their insights and best practices. Thank you for watching, and I hope this video has provided a helpful introduction to the world of site reliability engineering.